We're going to continue our study of right triangles today by talking about solving right triangles. Now, what do we mean when we say solve a right triangle? Well, if you're trying to solve a right triangle, you want to find all the measures of the sides and angles. Now, at this point, you can solve a right triangle if you know one side length and the measure of one acute angle. Let's take a look at example 1. We're given angle A, we're given side BC, and we know this is a right triangle. So the missing parts that we still need to find are angle B, AC, and AB. Let's start by finding angle B. Since we have a triangle, and we know that one of those angles is 51 degrees, and the other is a right angle, we can find the third angle by using the triangle sum theorem. So angle B is 180 minus the 90 minus the 51, which gives us 39. So angle B is 39 degrees. Next, let's find AC. Now AC is the leg that is adjacent to the 51 degree angle. BC is the leg that is opposite the 51 degree angle. Since we're looking at the opposite and adjacent legs, we'll want to use the tangent ratio. So tangent of 51 degrees is equal to 9 over AC. When you use trigonometry to solve, you want to make sure you're using an acute angle. We would never use angle C, that right angle there, to write a trig ratio. Now let's solve for AC. I'm going to multiply both sides by AC to get it out of the denominator, and then divide both sides by tangent of 51 degrees. That comes out to be about 7.3. Next, we're going to solve for AB. Now at this point, we've actually solved for two sides in a right triangle, so you could apply the Pythagorean theorem to find the third side. For practice, I'm going to use another trig ratio to solve for AB instead. So AB is the hypotenuse, and remember that the side given to us, BC, is opposite the 51 degree angle. Since we have the opposite leg in the hypotenuse, I'm going to use the sine ratio here. So sine of 51 is equal to 9 over AB. Now let's solve for AB. Multiply both sides by AB to get it out of the denominator, and then divide both sides by sine of 51 to get it by itself, and we get that AB is about 11.6. So now we have successfully solved this right triangle because we have found all the missing angles and sides. Take a look at example 2. Here we're given angle A, we're given side AB, and we still need to solve for angle B, AC, and BC. Let's start with angle B. To solve for angle B, we can again apply the triangle sum theorem and subtract 90 and 24 from 180 to get angle B. That leaves us with 66 degrees. Next, let's solve for AC. Now AC is adjacent to the 24 degree angle, and we are given the hypotenuse, AB. So with the adjacent leg and the hypotenuse, we're going to use the cosine ratio. So cosine of 24 is equal to AC over 14, and I'm going to solve for AC by multiplying both sides by 14. That leaves me with AC being about 12.8. Alright, and now we have to solve for BC. BC is opposite the 24 degree angle, and we're given the hypotenuse. So using the opposite leg in the hypotenuse, we're going to use the sine ratio. So sine of 24 is equal to BC over 14. Multiply both sides by 14, and that gives me that BC is about 5.7. Alright, let's look at example 3. In this example, we need to solve for angle B, we need to solve for AC and BC. We'll start with angle B, and we'll apply the triangle sum theorem. So subtract 90 and 40 from 180, and that leaves me with 50. So angle B is 50 degrees. Next, we're going to solve for AC. Since AC is adjacent to the 40-degree angle, and we're given the hypotenuse, 3, we can use the cosine ratio to solve for AC. So cosine of 40 degrees is equal to AC over 3. And then we can solve for AC by multiplying both sides by 3, which gives us AC being about 2.3. Next, we'll solve for BC. BC is the opposite leg to the 40-degree angle, and we were given the hypotenuse. So with the opposite side and the hypotenuse, I'm going to use the sine ratio. So sine of 40 degrees is equal to BC over 3. We can multiply both sides by 3 and get that BC is about 1.9. Alright, here's our last example today. It says to solve the right triangle and to round decimal answers to the nearest tenth. So let's start by finding the measure of angle B. We'll again use the triangle sum theorem. We know we have a right triangle, so we have a 90-degree angle and a 42-degree angle here. Subtract those both from 180 and we get that the measure of angle B is equal to 48 degrees. Now let's solve for BC. Since BC is opposite the 42-degree angle and we're given the adjacent side, that means we should use the tangent ratio to solve for BC. So tangent of 42 degrees is equal to BC over 70, and we can multiply both sides by 70, and that leaves us with BC being about 63. Lastly, we're going to solve for AB. Now, AB is the hypotenuse, and we were given the adjacent side. With the adjacent side and the hypotenuse, we want to use the cosine ratio. So cosine of 42 degrees is equal to 70 over AB, and then we'll solve for AB. So we'll multiply both sides by AB to get it out of the denominator, and then divide both sides by cosine of 42 degrees. That gives me AB is about 94.2. So in all of these examples, we used the triangle sum theorem to help us find the measure of any missing angles, and then we used trig ratios in order to solve for any missing sides. You want to relate whichever side that you are trying to solve for with any sides that are given to you, and relate those sides to the angle that's given to you, and then write our trig ratio. Solving that trig ratio, you'll be able to solve for any missing sides.